discussion of temperature and heat is essential to an explanation of how water becomes steam. Temperature is a measurement of the molecular motion within a substance. Water in a teapot, for example. Faster-moving molecules result in higher temperature. We measure temperature on a thermometer, which sets the freezing point of water at 32 degrees Fahrenheit and boiling point of water at 212 degrees Fahrenheit at sea level. Heat is a measurement of the movement or transfer of energy from a body with a higher temperature to a body with a lower temperature. We measure heat in British thermal units, BTU or kilojoule. 1 BTU is the amount of heat required to raise the temperature of 1 pound of water 1 degree Fahrenheit. In SI units, the kilojoule is equal to a kilowatt second. Water can absorb only so much heat. This is called sensible heat because it produces a temperature change that can be measured. The amount of sensible heat that is required to raise the temperature of water from freezing to boiling is called the heat of the saturated liquid. At sea level, atmospheric pressure is about 180 BTU per pound of water. Adding more heat to water has no effect on temperature. Instead, it causes the water to change state, or vaporize, from a liquid to a gas. About 970 BTU of additional heat is required to vaporize 1 pound of water into 1 pound of steam. This is called latent heat because it cannot be measured by a thermometer. Water is made up of hydrogen and oxygen atoms. At lower temperatures, these molecules are loosely bonded to each other. When heat is transferred to the water, the molecules begin to vibrate and the temperature starts to rise. As the heat increases, the molecules vibrate more and more until the bond holding them together is severely weakened. When sufficient heat has been transferred to the water to break the bonds, the molecules explode apart, creating steam. After the steam has been transported to the heat exchanger, it gives up its latent heat to raise the temperature of some product or to power some operation. As the steam gives up its latent heat to the work effort, it condenses back into water. Heat transfer takes place in 3 ways: conduction, convection, and radiation. Let's take a closer look. Conduction is the form of heat transfer that takes place within a solid. Conduction causes the handle of a cast iron frying pan to be nearly as hot as the bottom. Conduction occurs within a solid or between 2 solids in contact with each other. It is generally believed that conduction occurs on the atomic level, much as the conduction of electricity takes place. Free electrons transport thermal energy from molecule to molecule away from the heat source. Convection is the form of heat transfer that takes place within gases or liquids or between solids and liquids or gases. Convection causes the air from your heating system to be distributed throughout the room. Convection also requires physical contact. It takes place because of the difference in density in fluids as they are heated and cooled. Liquids or gases are heated and become less dense and rise. As they cool, they become denser and fall. In a system, this cycle of movement is called a convection current. Radiation is the form of heat transfer that takes place between 2 bodies that aren't in physical contact. Radiation causes sunburns that many of us get when we've stayed out in the sun for too long. Radiation is the only form of heat transfer that requires no physical contact. While we do know that it occurs because of electromagnetic radiation, usually in the infrared band, much of our understanding of it is still theoretical. We do know that it can take place between 2 bodies separated by a vacuum and is partially explained by wave theory and quantum mechanics.